Thank you, Milena, for the nice introduction. First, do you see my presentation?
Yeah, we see your presentation.
Okay, thank you. I will speak about the black carbon concentration we have measured in Skopje. And I'm starting just to indicate with this photo of blank filter and exposed filter in Skopje during the winter area. This is Teflon filters. We take it in our lab. So we see why black carbon measurements are quite important for our urban areas in Macedonia, because there was a lot of talk from previous panelists about the black carbon. I will only shortly address this. Black carbon has been recently identified as aerosol component of particular interest and has become a research target for climate change and health impact assessment. This is most efficient light absorbing species and therefore very interesting for climate change impacts, and also as all combustion related aerosols, this is very important for the health effects, and because all these particles are considered more harmful than other anthropogenic particles and natural particle components. This is usually product of incomplete combustion. Black carbon is product of incomplete combustion of carbonaceous fuels composed of aggregates, very small aggregates, usually in chains. Strongly absorbs visible light. It is refractory, insoluble in water, as per definition, organic solvents, and thus very resistant to chemical transformation. Usually in the urban environments came from traffic or residential heating. And it's very important for our Balkan area. As you can see on the right, there are pictures from Skopje. You will probably recognize them: Skopje, Sarajevo, and Belgrade. And Balkan urban areas have the poorest air quality in Europe, and from some data even globally. Most of the region capitals exceed European annual limit value for particulate matter 2.5. This includes Skopje, Sofia, Sarajevo, Podgorica, and Pristina. And if we refer to the latest guidelines from WHO, this then all capitals are above the limit values for PM 2.5. And in most of these cities, biomass burning, fuel oil burning, and traffic are identified as the most important air pollution sources. But we still don't have regular, black carbon monitoring or available black carbon monitoring in all of these Balkan capitals. What we have done, we have measured black carbon concentration at two sites. One is urban background site in Skopje, and one is traffic exposed site also in Skopje from January to August, intermittently, because we have only one unit available. Urban background station is, or Karpoš area, is located in a residential area in the western part of the city. This is a station located in the schoolyard, away from the main traffic, and only with slow traffic streets surround this area. On the other side, exposed site is located near the major intersection, but also there is in close proximity, there is a cement factory, quarries, and large residential area. So this is very mixed impact. The site is with very mixed impacts. With the support of aerosol, as the previous panelists mentioned, we use their altimeter, and with the support of the Ministry of Environment and Physical Planning, we construct this unit with the equipment from aerosol and install it in the stations from the ministry, operated by the Ministry of Environment from the State Monitoring Network. We used 7 wavelength altimeter, aetalometer model IA33. Aetalometer readings this is new unit, so they were corrected in the real time for multiple scattering and filter matrix and loading effects. The unit has this dual spot technology. Data were analyzed using their CAD software, and we have used aetalometer model for estimating the contribution of biomass burning and fossil fuels to total black carbon concentration. In addition to this, we also sample gravimetrically PM2.5. We have sampled on Teflon filters using low volume samplers, and we have analyzed potassium and other major and trace elements using X-ray fluorescence and water soluble ion analysis. 1 hour average data for the real-time data. We have taken the data from the ministry operated network or state monitoring network. They use beta attenuation monitors for particulate monitoring and the standard reference methods for carbon monoxide and nitrogen dioxide. And what we have found, briefly to inform, first of all, urban background during the cold season. During the cold season, black carbon and particulate matter 2.5 correlate quite well, or they have the same trends. The values are very high for black carbon, extremely among the highest we have found in the literature. But this is not the case for the warm season. The values are much smaller and there is no correlation. This is similar for the other pollutants, other species, particulate matters, carbon monoxide and nitrogen dioxide correlate well during the cold season or during the heating season, but not during the warm season. If we review the data or analyze the data, there is a strong seasonal variation. As you can see, much smaller values are found during the warm season compared to cold season for black carbon and for particulate matter. Regression analysis for the data during the cold season shows very high R-squared values between black carbon and particulate matter and black carbon and carbon monoxide, but low value between black carbon and nitrogen dioxide, which suggests that probably because nitrogen dioxide is a marker for traffic pollution, that the traffic pollution is not the main source of background site for background site area. And during the warm season, there is a quite different pattern. We have high R-squared values for black carbon and nitrogen dioxides and black carbon and carbon monoxides, but very low value between black carbon and particulate matter 2.5. For the traffic exposed site, we have similar situation. During the cold season, we have good correlation between black carbon and particulate matter. Not so much as the case for the background site, but during the warm season, there is almost no correlation between black carbon and particulate matter. And again, very strong seasonal variation. We have high values for black carbon in cold season and significantly lower values during the warm season. During also the same goes for particulate matter. Regression analysis here showed the good correlation between black carbon and particulate matter during the winter, and also black carbon and carbon monoxide, but much lower between the black carbon and nitrogen dioxide. For the warm time, or for the warm season, there is a very good or very high value between black carbon and nitrogen dioxide, which indicate that actually during the warm season, traffic is probably the dominant source of pollution. But again, the values are much lower compared to the values measured during the cold season. There is also a strong diurnal variation during the cold season, but not during the warm season. As you can see, we have for the urban background site, we have 2 peaks, one in the morning, around from 7 to to 10 o'clock, which is smaller. And during the evening, late evening and late night hours, there is a larger peak. And this indicated that probably this pollution, they have much significantly higher values during this period for both sides, as we can see. While on the warm season, there is no such distinctive pattern. There is no such distinctive pattern, and we can see even on the traffic exposed size, these peaks are high for both periods, the morning and during the late or early evening, let's say from 5 to 8 p.m. And what is interesting, the values, midday values, when there is a normal traffic, they are similar during the warm season, the cold and the warm season, when there is no, probably the pollution from the biomass burning is significantly lower during the day, and the height of mixing height is higher. The values for biomass burning, percentage of biomass burning is much lower during the midday. So this is shown here exactly on the diurnal variation of this traffic exposed site. We also, as I mentioned, use aetalometer model from Sandra Devi, and we use a coefficient 1 for fossil fuels and 2 for biomass burning. We currently work to model this let's say our coefficients. We're still doing this, and hopefully soon we have our specific for our conditions. But for now, we make a sensitivity analysis, and we found that 1 and 2 are probably the best options. And as you can see on the chart, there are high values of biomass burning in percentage reaching up to 90% during the night hours, and this is a similar pattern during the entire measurement program. But also we can see that these values are much smaller during the hot season, warm season, during the summer. This is traffic exposed site, actually. If we review the diurnal pattern, actually there is again quite significant B-model distribution, one in the late night, and there is a flat line between during the noon or midday, and again in the evening, the percentage of the biomass burning increasing, which actually goes in line with the usage of domestic heating systems. They usually start in the afternoon, and to some extent during the night around 10, 11, and slowly or gradually this is reducing, the amount of particulates reduce during the night. When in the morning it starts again. We don't have this diurnal pattern during the warm season. It's totally similar and flat, and during the warm season, the percentage goes only from 10 to 20% of biomass burning. It's not that we don't have it during the warm season, because there are a lot of agricultural burnings, even wildfires we have this summer, which is very specific. So more or less, these data indicate that biomass burning currently lead the pollution or is most important source of pollution in our urban areas. We currently monitoring other city, not Skopje. We move it from start of September to Kavadarci to see, because there is a mixture of industry and traffic and domestic or biomass burning for residential heating. And we're still working on the results, but from what we have found for now is definitely the biomass burning and high black carbon values are a very important source of pollution in Skopje urban area, and probably similar in most of the Balkan urban areas. Thank you. I was short and
Thank you, Dr. Mirakoviski, for this nice
I should
presentation.
change this.
You
I don't know how to.
somehow. Thanks. Is any question? We are late bit with next session. No, we know that there is a problem about with soot in our region due that a lot of domestic heating sources, and so that is characteristic of whole area from where we are. Thank you very much. So we are finished with this session.